So we're going to finish up with piecewise functions today. Yesterday we started looking at how to graph them, how to interpret what that function notation looks like. We're going to do a few more of those today, as well as reversing that process. I'm going to give you a few that are already graphed, and you're going to tell me what function fits it. Okay? So our first one, we look at our original function here. And we look at where does the break happen? Where is there a change in the function? For what x value do we change? At 1. All right? So when x is 1 here, we have to look at two different functions happening. So we're going to draw a vertical line at 1, and that visually will help us make that break. The first function is, it says y equals negative x squared. What shape would that be? It is a parabola. Is it going to open up or down? It's going to open down. How do we know that? Good, the negative in front. So we have an upside down parabola. Have we done anything besides flipping it upside down? In other words, have we stretched it, compressed it, left-right shifts, anything like that? Okay, so it's our basic parent function. It's just upside down. So we can plot some points. For that first one, we have 0, 0 being the vertex. What are some other points that would fit? 1, negative 1. Now, is that going to be an open or closed circle? Can I be at 1? No. So I am going to put a dot at 1, negative 1, but it's going to be an open dot. And then I also have one at its reflected point. At negative 1, negative 1. What about if I put a negative 2 in? What do I get? Negative 4. All right. So that should be enough points to go ahead and draw your parabola. Remember, we're only drawing that part of it. Okay. And now on the right-hand side, we have our separate function, the 1/3 x plus 1. What shape would that be? It's a line. What do we know about the line? Its slope is 1/3 and its y-intercept is 1. Okay, so we're going to start with a y-intercept of 1. We're going to do a slope of 1/3. So up 1 over 3. And then remember, we're only going to color in the dots from the dotted line over to the right. Okay, for values of x. All right. Will we have a solid or open dot at the end of that? How do we know it's solid? Yes, because of this equal to sign here, we know that we are going to have a solid dot. Now, where exactly is that dot located? It's a little trickier on this one because we were going up 1 over 3. So we're going to hit that dotted line where x equals 1 in the middle of a grid. Where are we going to hit it? You can always tell by plugging that number into your function. All right, we want to know what is the value for y when x is 1. That's where our dotted line is. So if we put a 1 in there, 1/3 times 1 is 1/3. 1/3 plus 1 would be 1 1/3 or 4/3. So you should have a dot at coordinates 1 4/3. Okay? We okay with the graph? All right. Domain and range for this one. Are there any x values that get skipped over? And you can tell that based on this part right here. The top equation is being used for values of x that are less than 1. The bottom one is being used for values of x that are 1 or higher. So there's no break, there's no gap in there. There are no x values that aren't being used. So my domain would include everything from negative infinity to positive infinity. But when I look at the range, there is a gap. in this little section right in here, there's a break. There's nothing graphed there. So when I list my range, I have to keep that in mind. I'm going to start down at negative infinity and picture moving up the y-axis. Everything in this lower half of my coordinate plane is going to get used by that parabola piece. All right, because this part continues down forever. So I'm going to start at negative infinity, and I'm going to go up to what? Where do I stop? At 0. There's a break happening after the 0. I do include 0. It's the vertex of that parabola part. But because there's a little jump, I'm going to have to use that union symbol and say I'm just combining these two separate intervals. Now continue up the y-axis past that 0. Where does the green line pick it up again? At 4/3. That's why I had you calculate what that value is. Okay? We pick it up again at 4/3 and it continues on to positive infinity. Okay? Is it a function? Remember we had that vertical line test. So look through it. Does it pass a vertical line test? It should. This right here tells me I'm dealing with a function, right? It's a piecewise function. It should pass a vertical line test. So it is a function. The one spot where students sometimes would say no, it's not, is where that break happens, where we drew that dotted line. But remember, an open circle here means we're getting really close to that value, but we're not actually going to hit that. So the only point that's really being graphed when x is 1 is this 4/3. Okay? We have 4 values to plug in. We have to make sure we plug them into the correct part of that piecewise function. So what are we going to use when we want to find h of 0? The top one, because 0 is less than 1. It fits that top domain. So we're going to use the top one. Negative 0 squared would be 0. Which one do I use for 1? h of 1. Now I have to go to the second one because it tells me x can equal 1 if I use the second function. So 1/3 times 1 plus 1 gets me 4/3. That's the one we calculated earlier. Which one should I use for 24? Second one. So 1/3 times 24 plus 1. What do we get? Okay. And the last one, which function do I use for a negative 7? Top one again. So we've got a negative times negative 7 squared. Negative 7 squared turns into a positive 49, but the negative in front will make it negative 49. Okay? So I'm going to pause the recording. What I want you to do at your tables is try this next one. Talk about where does the break happen, what shapes of the pieces will you have, and go ahead and get them graphed. So this one should have a break at negative 3 and another one at positive 2. The first one is what shape? The negative 2x minus 7. What shape is that? A line, yep. So we're going to start at negative 7 on the y-axis. We are going to do a slope of negative 2, which would be down 2 over 1. But I want this to be on the far left of my graph, right? I want it to be for values less than or equal to negative 3. So I'm going to move it up 2 and back 1 until I can find where I hit that point, that dotted line, and then I'll do a couple more just to get the angle right. I'm only going to draw that in here because that only works for values of x that are less than or equal to 3. Should it be a solid or open dot at the end? Solid. Okay. We'll get rid of these dots. All right. For the next piece, we are looking at that interval between negative 3 and positive 2, so the stuff in between the dotted lines. we want that one to just have a value of 7. So I'm up here at 7. And then open or close dots on the end of that. On both ends. Okay. And then for the last piece, we want it to be the values for x greater than or equal to 2. So we're on the far right side of our grid. We want to graph y equals x plus 1. So we're going to start at 1. We're going to do a positive 1 slope. And then I'm only going to draw that in on that portion of my graph. Open or close dot. Close dot on that one. All right. So, does it pass a vertical line test? Yes? All right. How about the domain? Negative infinity to positive infinity. All right. How about the range? Looks like I erased a little bit of mine there. Where were we at? -1 here? So range, the lowest value we have is -1. Does it include everything above that? Doesn't matter which part of the graph is using it, but are all the y values getting used above it? So my range starts at -1 and goes up to positive infinity. All right. Which function did you use for h of -3? Top one. All right. So -2 times -3 minus 7, and you got -1. Okay. For h of -1, which function do we use? The middle one. -1 fits in between -3 and 2. So answer is just a plain 7. H of 2. The bottom one, that's where it's equal to 2. So I put it in the bottom function. 2 plus 1. Should have a 3 for that. And the last one, h of 489. Bottom one. So 489 plus 1, we should be at 490. Some of them you can get by looking at the graph, right? The small numbers. Obviously, h of 489, you're not going to graph it that big. You'd have to plug it into the equation. All right. The last part that we're going to look at today, as I mentioned earlier, is the reverse. So what we have to do is figure out how many different parts to this graph are there? How many pieces in the piecewise function? How many different shapes and pieces do you see? 2. Where does the break happen? At x being 2? So we need an equation if x is less than 2, and we need an equation if x is greater than or equal to 2. How did I know which one to put the equal sign on? Yeah, look at your open and closed dots. So this parabola shape has an open dot, which means I'm getting close to the 2, but I'm not at 2. So for the top equation, for values of x that are less than 2, I need a basic parabola. I'm going to start picturing that parent function parabola, where we're at 0, 0, 1, 1, 2, 4, and the reflected points. And I'm going to compare that to the parabola that I'm given. What have I done to it? It's moved down, how far? 2 spaces. Could I take every point and move it down 2 spaces? The point here at 1, 1 moves down 2 and it hits my graph. 2, 4 moves down 2 and hits that open circle. So I haven't stretched or compressed it at all, right? It's the same width. I've just moved all my dots down 2. So how do I write an equation for a basic parabola that's been shifted down 2? X squared gets the parabola shape. A minus 2 after it moves everything down 2. Remember your transformations? Okay. Now, for the line part, the linear piece of my piecewise function, I need to know 2 things to write an equation for a line. I need a slope and I need a y-intercept. Can you tell the slope from the piece that I've given you? Find a couple dots. What's my slope? 2. Okay, so slope is 2. The other thing I said I needed is the y-intercept. I can't tell just by looking at the piece I have, but I could pretend I'm extending that line back and see where it hits the y-axis. So if I have a slope of 2, I'm going to reverse that, go down 2 and back 1, and it looks like I'm hitting the y-axis at a positive 1. That would be my y-intercept. So my equation would be 2x plus 1. Okay? Give me the range for this one. My lowest value is -2 down here. Do I use everything above it? Okay, so I'm going from -2 up to infinity. All right, looking at our next one, where do we have some breaks happening? At -1 and at 4? Okay, so I have one picture that is below -1. Can it equal it? In other words, if I put in here, if x is less than -1, do I actually want an equal sign on that? For my far left picture over here, I do, because it has a solid dot. Okay? Can you tell me the slope of that? It looks like we're going up 1 over 2. So it has a slope of 1/2. All right. Continue it up 1 over 2, and I'm hitting the y-axis at -2. Yes. Okay. So we've got the first piece done. I'm going to pause the recording. I want you guys to do the next 2 parts. And then also list the range. Looking at our next piece, we want to indicate that chunk. It's just a horizontal line at what level? 3. So y equals 3 if, what can you tell me about my x's? It's between what numbers? -1 and 4? Okay. Now, do I have equal signs on either of those? Which one? At the 4. There's a solid dot at 4. All right. And then looking at this one, let's try that again. Looking at the far right piece, can we tell the slope? I'm seeing dots there and there. So how much am I moving up? Up 3 over 1. So it has a positive 3 slope. And then I need the y-intercept. So I'm going to have to go down 3, back 1. And it looks like I'm hitting at -7. So that would be my y-intercept. And that works for which values? For x's that are greater than 4? Okay. Let's look at the range on this one because it's a little different. Remember, this one continues on down, right? So I'm starting at -infinity, and I'm going to stop when I get to that level. So from -infinity up to what? How do I figure out that height? Where that dot is. It's in between a grid, right? I want to know the value for y when x is -1. Yes? For the far left graph, which is this one here, plug a -1 in. We've got 1/2 times -1 minus 2. What do we get? -1/2 minus another 2. We're at -2.5. Okay. Do I include that? Yes. Okay. Then I make a jump. I'm going to move this down here. The next value that gets used for y is a 3, where we have that horizontal chunk. It's not an interval, it's just plain 3. So I use that set bracket notation to indicate just a single value since it's not an interval. We use the rounded and squared off brackets when we're talking about intervals. Then I make a jump again. Where do I pick it back up? At a 5. Can I equal that 5? No. Open circle means rounded bracket. I'm picking it up at 5 or just a little bit above 5, and I'm going up to infinity. Okay? All right, so homework today is a worksheet. I'll get that passed out.